Hello, in this video I'm going to explain how come a car can become airborne when it drives too fast over a hump. Let's start with the car stationary on the slope. Since net force is 0, the normal contact force must match the weight of the car exactly. But if the car is driving over the hump, then it becomes circular motion because the surface of the hump is part of a circular arc. So net force is no longer 0, the centripetal direction is downward, so normal contact force has got to be smaller than the weight now in order for the net force to be downward. In fact, applying Newton's second law onto the car, we get the downward weight minus the upward normal contact force to be equals to the required centripetal force mv squared over r. Rearrange the equation, so clearly the normal contact force is smaller than the weight by an amount that's equals to the required centripetal force. So if the car were to drive over the hump at a higher speed, then the required centripetal force will become larger and the normal contact force will become smaller. So as the speed becomes faster and faster, the normal contact force becomes smaller and smaller. There will come a time when the speed is so large that the normal contact force becomes 0. So writing the normal contact force to be 0, we can solve for the limiting speed when the car becomes airborne. So at this speed, the normal contact force has already dropped to 0. So this is the maximum downward net force that can be experienced by the car. If the car is going at a speed even higher than this maximum speed, it means that the car will not be able to find the required centripetal force for it to do this circular motion along the hump. Because the normal contact force has already dropped to 0. The downward net force cannot be larger than mg. So the car cannot keep up with the circular motion. It will leave the circular motion and becomes airborne. In fact, it becomes a projectile motion. Okay, that's all. Ta-ta!